AB Calculus, Notecard 42, Curve Sketching. This is the 42nd lesson in the Notecard series that's inspired by Stacy McMullen, formerly of Dallas Independent School District, who developed this Notecard system. Curve sketching. This may be my favorite lesson thus far in that it takes into account many of the various things we've done so far and kind of puts them all together. The first thing we're going to do is plot any given points on the grid for f. Second, find x and y-intercepts and vertical horizontal asymptotes. 3, find critical points and intervals where the function value is increasing or decreasing. 4, determine local maximum minimum points. 5, determine concavity and find points of inflection. And finally, 6, sketch in the curve. As always, these are going to be easier said than done, but they're not going to be too bad. The first thing we're going to do is unveil our analysis tools that we've looked at so far. And this one here, this relationship between f prime, and f double prime, is we have plus minus here, up arrow, down arrow, and then concave up, concave down, and right below on the f prime level we have plus or minus underneath the increasing decreasing, and then increasing decreasing underneath the concave up, concave down, and finally in the f double prime row we're going to have plus and minus below at the right. And these are going to really help us. The next thing we're going to do is take a pre-look at what kind of shape of curve we're going to be drawing. So if we make just like an XY coordinate, and each quadrant here represents a piece of the circle, or the shape of the circle we're going to be putting in place. So for instance, this upper right piece, our curve is going down from left to right and also has a concave down shape. So we're going to put negative for decreasing, negative for concave down. Lower right, we are increasing in concave up, so plus plus. The lower left, we are decreasing, but we are concave up. And in the upper left, we are increasing, function increasing, but we have a concave down shape. So we're going to plug these pieces in to our sketch for our graph where needed. Okay, consider the function f defined by f(x) equals quantity x squared minus 1 cubed. For what values of x is f increasing? Well, I'm going to put a pre-justification here. We're going to say f is increasing on a certain interval or intervals. I'm going to leave some space here. And why? Because f prime is greater than 0. Okay, we've pre-justified. Next, we're going to take the first derivative here of f of x, and to do that, we're going to say f prime of x is equal to, we take this 3 out front, so we have 3 times quantity x squared minus 1, and then we're going to have 3 for the power, 3 minus 1, which is 2, times, using the chain rule, the derivative of the inside, which is 2x. So what we have here is f prime of x is equal to 6x times quantity x squared minus 1 squared. And then we can set f prime of x equal to 0, and to do that we're going to say, if we divide by 6, we're just going to rewrite f prime of x as x times quantity x squared minus 1 squared. And then we know that our critical numbers are going to be first x equals 0, and then for this quantity x squared minus 1 squared, if we set quantity x squared minus 1 squared equal to 0, we're going to have essentially, if we take the square root of both sides, we're going to have 0 is equal to x squared minus 1. And using the difference of squares, that's going to bring us x minus 1 is equal to 0, and also x plus 1 is equal to 0. So our other critical numbers are going to be x equals negative 1, and I'm going to put x equals 0, and x equals 1. And these are the totality of our critical numbers. So now we're going to create our number line for analysis right up here and put them in place. We're going to have negative 1, 0, 1. And up above number line, we're going to put f prime, and below we're going to put f. So let's take our analysis based on this version right here, and f prime of x equals x times 20x squared minus 1 squared. And so for a number less than negative 1, we're going to have a negative, and this, because we're squaring this thing right here, this factor on the right, it's always going to be positive. So the increase or decrease is going to be determined solely by the sign of this x right here. So if x is less than negative 1, negative, decreasing. Less than 0, negative, decreasing. Greater than 0, increasing. Greater than 1, increasing. So the underlying function is decreasing from negative infinity to negative 1 and continues to decrease until 0, and then starts increasing at 0 and continues to increase up to less than infinity. And so f is increasing on 0 up to less than infinity because f prime is greater than 0. And B, find the x and y coordinates of the relative max and relative min. Justify. Well, we have a relative min at x equals 0 because f prime changes from negative to positive. And then also, what's really going to help us here is finding out what these points are. And as far as x and y coordinates, we already have a relative min. Okay, our x coordinate's going to be 0. Our y coordinate's going to be what we get when we plug in. So we're going to say f of 0 is going to be quantity 0 squared minus 1 cubed. So that's going to be negative 1. So negative 1, that's going to be our relative minimum. And while we're at it, let's find some of these other points. If we have we'll find our x-intercepts. That's our y-intercept, right? Our x-intercepts we can get by setting the original function equal to 0. So we'll say 0 is equal to quantity x squared minus 1 cubed. And if we cube root these, we get 0 is equal to x squared minus 1. And then working to the right, we're going to have, using our different squares, we're going to have x equals negative 1, x equals 1. So those are going to be also points. Okay? So I'm going to put to the right here, x-intercepts. We have negative 1, comma 0, and also 1, comma 0. Okay, these 3 points we have so far are going to help us in our sketch. For what values of x is the graph of f concave up? Well, we're going to find our second derivative, but before that I'm going to rewrite our first derivative, which is going to be 6x times quantity x squared minus 1 squared. And to find our second derivative, I'm going to consider this as a product of two functions. I'm going to use a product. I'm going to call this one on the left u and this one on the right v. I'm going to make my little box that helps us analyze here. Okay, here we go. So I'm going to say u prime, v prime. So u is going to be 6x, and u prime is 6. V is going to be this 20x squared minus 1 squared, and the v prime is going to be, we multiply 2 out front. Do this a little bit. 2 out front times 20x squared minus 1. And 2 minus 1 is just going to be 1 times 2x. So simplifying, we're going to get 4x times quantity x squared minus 1. Okay, uv prime plus du prime. So uv prime is going to be 6x times 4x, or 24x squared, times x squared minus 1, plus uv prime, or excuse me, vu prime is going to be 6 times 20x squared minus 1 squared. And so now we're going to find a common factor here. And our common factor here is going to be 6 from each of these things here. So we got 6. And then we have this x squared minus 1. And that's going to be times what do we have left here? Well, we're going to have 4x squared. Right, that's where that comes from. And we're going to have plus, well, we're going to have 1 left after we factor out that 6. So we're going to have x squared minus 1. And yeah, we already took that out, so that's what we have left. So f double prime is equal to 6 times 20x squared minus 1 times, we have 4x squared plus x squared, so we have 5x squared minus 1. And so we set each of these factors equal to 0, so we can say x squared minus 1 is equal to 0. And so using the difference of squares, we're going to have x is equal to negative 1, and x is equal to 1. And then if we set this 5x squared minus 1 equal to 0, and we use factor using the difference of squares, we have square root of 5x minus 1 equals 0, and we also have square root of 5x plus 1 is equal to 0. In solving for x, we're going to have x is equal to 1 over square root of 5, and then we're also going to have x is equal to negative 1 over square root of 5. So all these things here, I'm going to circle all of them at once. What do we call all these things here? We call them PPOIs, potential points of inflection. Okay, now we're going to make our number line, and we have 4 numbers on this number line. I'm going to put f double prime above and f below, and the first one we have on the left is negative 1, and then we have negative 1, over square root of 5, and then we have positive 1 over square root of 5, and then we have 1. So we're just going to see what's going on here, and we can take the factored form of these if we want to, and we'll pick a number less than -1. Well, we're going to have, like, that'll be positive here, and this is going to be positive here, so we're going to be concave up. Okay. And then between -1 and -1 over square root of 5, we're going to have a sign change. So we're going to be concave down. And then if we plug in 0, we're going to get a negative times a negative, or concave up. We're going to have between 1 over square root of 5 and 1, we are going to be concave down. And then we have a sign change greater than 1, or concave up. So there we have that. So a lot of changes in concavity here. For what values of x is the graph of f concave up? Well, f is concave up on, we have negative infinity to -1 union 1 -1 over square root of 5 comma 1 over square root of 5. So that's another interval of concave up. And then finally, we have greater than 1 less than infinity. So that's really all that analysis. Now finally, sketch the graph of f. So what I'm going to do that is right here. I'm going to make a little xy coordinate plane. Okay. And already we know we have a relative or minimum at 0, -1. We know we have x-intercepts at -1, 0, and also at 1, 0. Let me see, that one might be in the way a little bit. And I'm going to say 1, 0 also. Okay, let's draw the curve here. And we also have -1 over square root of 5. So I'll put this -1 over square root of 5, and then 1 over square root of 5, because they're going to be crucial values in our graph. Okay, let's go here. First, up here we have negative between -infinity and -1, and concave up. And so that's going to be negative on top, positive on bottom. So that's going to be this looking piece right here in the lower left. So we're going to come right here, and we know that we have the x-intercept, so that's going to be right there. We know that. Okay, now the next piece we have, f prime is still negative, the function is still decreasing, but we're going to be concave down. So we're going to have negative, negative, and what does that look like? Well, it's going to be this piece right here, negative, negative. So we take our negative negative, and it's going to be this looking piece right here. I'm drawing right over that 1/5. So that's our second piece. Next, between negative 1 over square root of 5 to 0, we're going to be decreasing, but concave up. And what does decreasing concave up look like? Decreasing concave up is going to be like this lower left piece. So things are going to come like this. Okay? And then between 0 and 1/5, we're going to change to increasing, but also concave up. So what does increasing concave up look like? This piece right here. So here we have this piece here. And then for greater than 1 over square root of 5, we're still increasing, but now we're concave down. So plus minus is going to look like this thing right here, the upper left piece. So we're going to go like this, and we know we touch our x-intercept here. And finally, 1 to infinity, we're going to be plus plus. And what does plus plus look like? This thing right here. It's going to look like this. So that is what the sketch of our graph looks like. And it so happens that I graphed this on the calculator, at least entered the function. And I'm going to, so there's our function. We press enter. And that's kind of what it looks like. Let's zoom in a little bit just to get a better look. Menu, window zoom, window settings. I'm going to go like from -2 to 2, and then come down here. I guess I'll go -2 to -2 here. Okay, tab down, press OK. Minimums must be smaller than maximums. Here we go. Let's do this. Yeah, now it should work. There we go. See, we have our x-intercept of -1. We have a changed concavity here at -1 over square root of 5. Our relative and actually absolute minimum here at -1. At what's that minimum of -1 at x equals 0, and so forth. So anyway, that's it. I hope this has been helpful to you. Good luck, and thanks for viewing.